Solid-state batteries are the buzzword in the battery landscape right now, hailed as the game-changing technology that could transform electric vehicles and portable gadgets. But do they live up to the hype? The answer isn't entirely straightforward yet. A recent breakthrough from TDK Corporation, a leading name in the electronic sector, might just change the narrative. They've unveiled a groundbreaking material for solid-state batteries that boasts an incredible 100 times higher energy density than current options. This innovation could be revolutionary. Picture electric cars that can cover significantly longer distances on a single charge, or smartphones that can go days without needing to be plugged in. It's an exciting vision, but there's more to unpack. So how did TDK pull this off, and what implications does it have for the EV industry? Let's dive in and explore. For electric car drivers, the worry of running out of battery before reaching their destination, known as range anxiety, is a major hurdle when considering a switch from gas-powered vehicles. Fortunately, TDK's latest advancement shines a hopeful light on the future of EVs. Reminiscent of the brand's iconic cassette tapes from years past, TDK has developed a new type of battery technology, a solid-state battery. Unlike traditional lithium-ion batteries that use a liquid electrolyte, solid-state batteries rely on a solid material for their internal workings. The solid-state design holds the key to the breakthrough. TDK's innovation boasts a massive leap in power compared to their previous attempts. Imagine a car battery that acts like a supersized gas tank, allowing you to travel much farther on a single charge. This new battery packs a whopping 100 times more energy than its predecessors. Placed inside a smartwatch, the new battery could keep a device running multiple times longer than current battery technologies. The Apple Watch currently lasts up to 72 hours in low power mode before it needs recharging, meaning it could potentially last several weeks with improved battery life. Other potential applications beyond wearables could include environmental sensors, according to TDK. While the initial application of this technology targets smaller devices like headphones and smartwatches, the ultimate goal is to scale it up for electric cars. With this powerhouse battery, electric vehicles could potentially travel a staggering 1,500 kilometers, 930 miles, on a single charge. That's more than 3 times the range of most EVs on the road today. This significant improvement would drastically reduce range anxiety and make electric cars a far more appealing option for drivers who frequently travel long distances. The benefits extend beyond just range. Solid-state batteries boast a safety advantage because they eliminate the risk of flammable liquids present in traditional lithium-ion batteries. Additionally, they may offer much faster charging times, significantly reducing the time spent waiting at charging stations. This translates to quicker commutes and less disruption to daily routines. Niroj Sat, the CEO of TDK, isn't shy about his enthusiasm for the company's breakthrough. He envisions their newly developed solid-state battery material playing a pivotal role in a large-scale shift towards a more sustainable, energy-efficient future. This technology has the potential to revolutionize the way we power our society. However, the path from groundbreaking innovation to widespread adoption isn't always smooth. Unlike conventional lithium-ion batteries that use a liquid electrolyte, TDK's solid-state design relies on a solid ceramic compound made of oxides. This solid ceramic acts as a bridge for lithium ions to flow between the battery's two components, the lithium alloy anode and the cathode. While this solid approach offers significant advantages, it also presents some technical hurdles. We're on the cusp of a transportation revolution, with electric vehicles powered by safe, long-range solid-state batteries becoming a reality. This shift has the potential to drastically reduce our dependence on fossil fuels and pave the way for a cleaner, more sustainable future for our planet. When should we expect to see TDK's new battery in the market? The road to widespread adoption of solid-state batteries may be longer than some initially anticipated. Motion, a consultancy specializing in the battery market, throws some cold water on our enthusiasm, suggesting that we might not see this technology reach the mass market until 2035. This delay is primarily driven by cost. Solid-state batteries are even more expensive to produce than their lithium-ion counterparts. While a typical EV battery currently accounts for roughly one-third of the entire car's cost, the figure jumps to a staggering 50% for the Neo with its semi-solid-state battery, and the price would likely be even higher for a pure solid-state model. Iola Hughes, a Rho Motion analyst, sheds light on the reasons behind this delay. Solid-state batteries have been a topic of intense interest within the battery industry for quite some time, she acknowledges. However, a consistent theme has emerged: delays and missed targets. The reality, Mishu explains, is that progress is happening incrementally. While technical advancements like TDK's new material are exciting, the major hurdles lie in cost and scalability. Manufacturing these batteries needs to become significantly cheaper and more efficient before they can truly compete with lithium-ion technology. Solid-state batteries also face some technical challenges that require further refinement. One concern is the inherent brittleness of the solid electrolyte material. This brittleness has the potential to negatively impact the battery's lifespan, especially during repeated charging and discharging cycles. Additionally, solid-state batteries tend to perform poorly in cold temperatures, which could limit their range and effectiveness in certain climates. Despite these challenges, Mishu highlights a potential niche where solid-state batteries could offer a significant advantage. Electric-powered heavy trucks, for example, may not be well suited for lithium-ion technology due to the limitations on range and charging time. Solid-state batteries, with their potential for longer range and faster charging, could be a game-changer for the electrification of heavy-duty vehicles. Solid-state batteries are considered safer due to the absence of a liquid electrolyte, which is a potential fire hazard in traditional lithium-ion batteries. The use of solid materials in the battery's construction enhances its stability and reduces the risk of thermal runaway, making it a more reliable and secure option for powering electric vehicles. The potential impact of TDK's breakthrough extends beyond individual consumers to the automotive industry as a whole. Car makers have been striving to overcome consumer hesitance towards electric vehicles, particularly among those who rely on their cars for long journeys. By offering a solution to range anxiety and enhancing the overall performance of EVs, solid-state batteries could be a game-changer in the push towards sustainable transportation. In recent years, there's been a growing emphasis on transitioning towards cleaner and more efficient modes of transportation to combat climate change and reduce reliance on fossil fuels. Electric vehicles have emerged as a promising alternative to traditional internal combustion engine cars, offering lower emissions,